So now today in this class we have to discuss about certain MCQ question which is based on heat transfer. Before to proceed the forward things, we should know about there is an heat transfer. Heat transfer is nothing but what? Transmission or a mode of heat transfer. This mode of heat transfer is always going to be based on the three important factors. One is called as conduction, second is called convection, and third is called as a radiation. So these are the three important processes which will be takes place while transferring the heat energy. Heat is nothing but what? And the quantity of the or is the amount of energy that contained inside the body. That is what we call as a heat. And the directional flow of a heat is called as a temperature. Directional flow of heat energy is called as a temperature. Okay. Now here, in the first question, so in the first question, what you have? The thickness of a metallic plate is, here let us consider solution for the first question. Solution for the first question now. The first question here, the thickness of a metallic plate. Imagine this is we call as a metallic plate. We call this one as a metallic plate. We call this is. It's a metallic plate whose thickness is given. How much is the thickness is given? The thickness of the metallic plate, that is X or L is equals to is 0.4 centimeter is the thickness is given. The temperature between the two surfaces is 20 degrees Celsius. This is the first surface or first phase. This is the second phase. This is second phase. Here there is a temperature difference, theta 1 and theta 2. Therefore, the delta theta is equals to 20 degrees Celsius is the corresponding temperature is given. Then, quantity of heat flowing per second is, there is an heat energy is flowing per second is given as, that is the heat energy flows per second is given as 50 calories. It is given as 50 calories. Then the cross section area of a given metallic plate is, there is an area of cross section A is equals to, the area is given as 5 centimeters square. 5 centimeter square. This is a given condition. Now let's solve this. How we can solve the condition? We know that from the statement of thermal conductivity, the amount of heat energy flows is directly proportional to cross section area and temperature difference between the two phases, theta 1 difference to the theta 2, and per unit time for this with the given interval of time, directly proportional and inversely proportional to the separation distance between the two phases of the given body. And if I remove this proportion value, we get this is Q is equals to Ka. This is theta 1 difference, theta 2 whole divided by, this is X into T. This is we call the statement of a coefficient of thermal conductivity. This energy in CGS, it is measured as a calories. In SI, it is measured as a joules. Then amount of heat energy flows per second. Per second means the rate. We call as the rate at which the heat energy flows is called as a heat current. That is Q by T. Q by T is equals to Ka. This can be written as the delta theta whole divided by X. So this is the given equation. Now we can apply this. For this given problem, I am applying the given equation. Apply for this, what do you get? The amount of heat energy flows. Heat always going to be. Temperature always referred as what? Temperature is nothing but what? Directional flow of an heat energy. Directional flow of an heat energy is called as the temperature. Therefore, then the time taken to transfer the heat energy from first phase to the second phase is given as how much the energy is 50 calories. So this is 50 calories is equals to, we have to calculate, so there is a coefficient of thermal conductivity. So how much is the coefficient of thermal conductivity is given for the given condition? So there is a K value. So we have to calculate the K value associated with the given substance. Then keep it as it is. Then what is the cross section area is given? The cross section area is 5 centimeters square into temperature is given 20. Temperature is given as 20. Then the separation distance, that is the thickness is given. How much is the thickness? 0.4 centimeter. So 0.4 centimeter. All values are given in CGS. Then don't worry about that. All values are given in CGS. It means only one system is applied over here. Then simplify this. Then 50 is equals to K into 5. This is 5K into 20. This is divided by 0.4. This you can just simplify this. 5 ones are 5. 5 tens are 50. Then this will be 10 is equals to 20 times of K divided by 0.4. 20 times of, see this is 20 times of K divided by 0.4. Make a cross multiply. So this is 10 into 0.4 is equals to 20 times of coefficient of thermal conductivity. Then 10 into 0.4, you will get 4 is equals to 20 times of coefficient of thermal conductivity. We need to be find out, or we wish to find the value of a K. K is equals to, this is 4 divided by 20. 4 ones are 4 fives are 20. Then K is equals to 1 by 5, or you can write as a 0.2, because if I divide this K value, you will get 0.2 times. This is the given answer. Hence, option number, there is an option number, third is the correct one. Third option is the correct. Option number 3 is the correct one. Go for the second question now. In this question, here 2 bars of thermal conductivity is K and 3K. There are 2 bars are given. Solution for the second one. Solution for the second problem. Here this is the first bar is given. whose coefficient of thermal conductivity is given as K. And the second bar is given whose coefficient of thermal conductivity is 3K. Whose coefficient of thermal conductivity is 3K. And length is given for the first one, it is L1 is equals to 1 centimeter and L2 is equals to 2 centimeter respectively. Have the equal cross section area. Having equal cross section area, both will have the same cross section area. Area does not going to be changed, remains as it is. Then they are joined lengthwise, as shown in the figure. They are joining as a lengthwise. This is we call as a lengthwise. It is lengthwise is nothing but what here? Lengthwise is also called as a series. What is a series? Series is called as end to end connection. End to end connection, like this. So this is a one rod and this is the another rod. If I going to be joined at the end to end like this, so this is we call as a series connection. If this is going to be connected as like this is called as a parallel combination. Okay. Therefore, now according to the question, there is a series connection is given. Next one. As the temperature at the ends, this composite bar. What is a composite bar? We have the question there. Composite is nothing but what? Is the combination of more than one element. It is the combination of more than one element. It is the combination of more than one element. What composite is nothing but what? It is the combination of more than one element. That's why it is called as a composite. Therefore, as once it is called as a composite, then the temperature difference between the two bodies or two metal rod is given, that is 0 degree and 100 degrees Celsius. This is 0 degrees Celsius and this is we have 100 degrees Celsius. Then see the figure, then the temperature phi of the interface. We have to find the interface temperature. What is interface? Interface is always defined as it's the connection between or it's a link between the two faces. It is the separating boundary. It is the separation between two surfaces. Separation between the two surfaces. So it means it is going to link the two surfaces at one point. That is called as an interface. Therefore, now we have to calculate. There is a heat flows at this point. We have to be calculated according to the figure. Now we know that the heat energy flows from one end to the another end. That is a heat current. We call as a heat current. That heat current will remain same, unchanged. Therefore, we can write as a, say for example, this is as a, this metal rod we can call as a X and this we call as a Y. And we have to find out the interface temperature. That is the junction temperature. It is also called as the junction temperature. We know that from the given condition. What is the condition we have? The amount of the rate at which the heat energy flows in the first one. The first one is always equals to what we have for the second one. That is the heat energy flows for the second one. D by dq by dt in the second. It is always equal. Then we know the heat which is going to be flows inside the given composite rod is given as, this is K1 because thermal conductivity of the first one is different, K1 into, this is cross section area of the first is same, K1 into A. Then temperature we can write as a theta 1 minus theta because this is we call as the initial temperature as a theta 1. Then this temperature we have to calculate, and this is called as a theta. But in question it is given as a phi. We call as a phi only. We will write as a phi. Okay. We have to find out the temperature as a phi here. Then into. Then we can write whole divided by this is Ka theta 1 difference to the theta 2 divided by corresponding length is how much you have L1. So this is for the first metal rod. And go for the second one, what we have to write it is K2A into. So what is the junction temperature? We can write phi minus theta 2 whole divided by this is L2. From this given condition, look at the condition there. The cross section area from LHS, cross section area from RHS, both will be cancelled. Then we have there is K1 into theta 1 minus phi whole divided by this is L1 is equals to K2 into phi minus theta 2 whole divided by L2. By solving the condition we get by making cross multiply. You make a cross multiply over with this value. What you get now? See, this is K1 theta 1. We go with one more step ahead it is. So we will go with one more step. Don't worry. So this is, we can go with one more step solving by this equation. So this is equal here. So K1 theta 1 minus K1 phi whole divided by L1 is equals to this is K2 phi minus K2 into theta 2 whole divided by L2. Then make a cross multiply. By making cross multiplication. By making the cross multiplication, what do you get now? So L2 is multiplied here, L1 is multiplied at the RHS. This is K1 theta 1 L2 minus K1 phi L2 is equals to K2 phi L1 minus K2 theta 2 L1. You see here, phi term is over here and this phi term is over here because we have to find the value of a phi. Then both will make it one side and remaining things will make it one side by making the rearrangement. What is it now here? So this is K1 theta 1 L2. This minus will be written at this end. What it become now? Plus. So this is plus. This is K2 theta 2 L2 is equals to what I write now here? So this is K2 phi L1 minus from LHS to RHS it become plus. So this is K1 phi L2. Here in this RHS equation you find out there is a phi will be common. This is called the junction temperature. Take common this junction temperature. What you get now here? So this is K1 theta 1 L2 plus K2 theta 2 L2 is equals to, if I take the phi common, we get that is K2 L1 plus K1 L2 into phi. Then which implies the equation phi, keep it as it is there. Therefore phi is equals to K1 theta 1 L2 plus K2 theta 2 L2. So therefore K2 theta 2 L2 divided by this is K2 L1 plus K1 L2. Therefore, here we can get the condition clearly over there. So just a minute. Here K1 theta 1 L2 minus K1 phi L2, and here we get K1, and now here this will be K1 theta 1 L2, and this is K2, or this will be L1. This will be L1 it is, and now here this is L1 and this will be L2. So K theta 1, and this will be again, sorry, this will be L1, and this will be L1. Now you can substitute this formula for finding the given interface temperature. Use this formula. Using this formula, substitute the values. So phi is equals to K1. How much is the K1 you have? K. K1 is K into, what is the theta 1 temperature you have? Theta 1 temperature is 0 into, then next one L2 1 centimeter, 1 centimeter plus, then K2 3K, K2 is 3K into, then theta 2 is 100, theta 2 is 100 into, L1 is again, so there is an L1, so L2, sorry, so this L2 will be 2 and L1 will be 1 whole divided by this K2. K2 will be 3K. K2 will be 3K into 1 plus. So K1 is K into 1. Now you solve this, you will get phi is equals to, so this whole term will become 0. 3K into 100 into 1, this is 300 times of K. You will get 300 times of K. Then this is 3K into 1 divided by this is 3K plus, so this will be 2K. So this will be 2K you get. So this is 3 2s are, so 3 plus 2 5K. So this is 300K divided by 5K. So this is K cancel. So junction temperature will be, so 5 1s are 5 6 are 30. This is 60 degrees Celsius is the junction temperature. So this will be junction temperature. The temperature at the junction is 60 degrees Celsius. In the next question, here in the next question, you can just solve this condition related to the third problem. That is, one end of a metal rod of length 1 meter. One end of the metal rod of length 1 meter. So solution for the third question. So here we have a metal rod. So this is we call as a metal rod. It's a metal rod. The length of the metal rod is given, L is equals to 1 meter. The length is given as 1 meter. Cross section area is given as 100 centimeters square. Area is equals to 100 centimeters square. 100 centimeters square. Is maintained at 100 degrees Celsius. Maintained at a temperature. Temperature is equals to 100 degrees Celsius. The other end is maintained at 0 degrees Celsius. The other end is maintained at 0 degree Celsius. The quantity of heat transferred through the rod per minute is, the quantity of heat transferred per minute is, question mark. Coefficient of thermal conductivity of rod is given. The K value is given. What is the K value? 100 watt per meter Kelvin. That's all. So we have to find out the given values. That is nothing but what in terms we have to be calculated. Therefore, now we know that from the coefficient of thermal conductivity we have from coefficient of thermal conductivity we have, that is the rate at which the heat energy transferred is always equals to, this is Ka into delta theta divided by L or Ex. So the amount of heat energy transfer per minute is given as, that we have to be calculated. This will be question mark for us. Keep it as it is. The coefficient of thermal conductivity is given. How much it is? 100. Area of cross section is given 100. So this is 100 into, because this is in centimeter, we have to convert in meter. So 10 raised to minus 2 whole square is equals to, this is meter square. Then we can write 10 raised to minus 4. This is in terms of meter square. 100, that is 10 raised to minus 4 into temperature is given. How much the temperature is given? The first end. The first end is maintained at temperature. So this is 100 minus 0. So the temperature which is going to be maintained as what? This is 0 degrees Celsius, and this will be called as what? 100 degrees Celsius. Therefore, whole divided by the length is given as 1 meter. Then simplify this, you will get the answer as, so this is 100 into 100 into 10 raised to minus 4 into, this is 100. So 10 raised to plus 1 plus 2 plus 3 plus 4. So it means all this 4 will be cancelled and this will be cancelled. You will get what? 100. So this is Q by T is equals to 100. The option number, you see there, we have to be calculating minutes. So therefore, we have to, for 1 minute is equals to how many seconds? 60 seconds. So it means the time is in denominator. So therefore, this will be equals to, this is 66 into, the option number you can see, third one is the correct answer. 6 into 10 raised to plus 3. Therefore, next one we have a question which is related to the length and radii of two rods are made of same material are in the ratios. The ratio is given. The length and the radii of two rods are made with the same material are in the ratio. Length is given. L1 is to L2 is equals to 1 is to 2, and the radii is given. Radii is R1 is to R2 is equals to 2 is to 3. 2 is to 3 respectively. If the temperature difference between the ends of the two rods is same and steady state, the amount of heat flowing per second through them will be in the ratio. The amount of heat flows per unit time will be how much? By using this relation, once again we have to be calculated. We know that by using the coefficient of thermal conductivity relation, the amount of heat energy transferred Q by T is directly proportional to, where K is called as coefficient of thermal conductivity, which is kept constant. Okay, this is constant. Then A is called as a cross section area. Then the radius. It means pi r square is given. Pi r square. Then temperature is also maintained same. Divided by length will be different. That is L. So from this relation, heat energy flows per unit time is directly proportional to radius square and inversely proportional to length. That's all. Using this relation now. Using this relation, you can easily find out the corresponding values which is related to the given. So here we have, there is a Q1 by T. So this is Q by T times of 1 whole divided by Q by T times of 2. This is equals to. So there is Q1 is nothing but R1 square by R1 square by L1 whole divided by R2 square by L2. So this is equals to R1 square by L1 into L2 divided by R2 square. Therefore, we have R1 by R into L2 divided by L1. So this is equals to, now you just substitute the values, you get there is an, so R1 and R2s are given, L1 and L2 is also given. R1 and R2 is given how much it is? 2 and 3. So this will be 2 by 3 whole square into, then L2 is 2, L1 is 1. So this is 2 by 1. So this is 2 2s are 4. 4 divided by 9 into 2 by 1. This is 4 2s are 8. 8 by 9. Option number 3 is the correct answer. The third option is the correct one. Two rods of the same length and cross section are joined along the length. Thermal conductivity of the first and second are K1 and K2. The temperature of the free ends of the first and second rods are theta 1 and theta 2 respectively. The temperature of the common junction is, as I proved now earlier, solution for the fifth question. Imagine this is the slab we call as the composite slab. We call this is a composite slab, and this will be called as a junction. Okay, here we call this is a junction here. The junction temperature. So this theta is equals to question mark. You know very well this is we call theta 1. This is we call as a theta 2. We call as a theta 2. And this will be the length as L1 and this will be length as L2. Then we have to be find out but the cross section area A1 is equals to A2. Then we know that the junction temperature theta can be find out. As we earlier we proved, that is theta is equals to, as we know that K1, when the length will be kept constant. See there, if both will be having the same length, what the condition has been joined with they have the same length, they have been mentioned clearly there. If they have the same length, then the condition will be what we have to be applied. So first one, the temperature at this end we have to be calculated. The temperature we have to calculate how it is. See, this is the dq divided by dt of the first one is equals to dq of the dt to the second one. So this is k1a into this will be called theta 1 minus theta whole divided by L1. This equals to k2 a into theta minus theta 2 divided by L2. So here area and area will be cancel, then we can get the condition which is related to the given equation. If length will be same, that's all. If L1 is equals to L2, if L1 is equals to L2, then both will be cancelled. Then area will be cancelled. Then simplify the given condition. What do you get now? So this is K1 theta 1 minus K1 theta is equals to K1 theta 1 minus K1 theta is equals to K2 theta minus K2 theta 2. Then rearrange the terms, we get K1 theta 1, K1 theta 1 minus K2. So minus will be from the RHS to LHS, it become plus K2 theta 2 is equals to K2 theta plus K1 theta. Therefore, take theta as a common. K1 theta 1 plus K2 theta 2 is equals to theta common K2 plus K1 or K1 plus K2. Theta is equals to K1 theta 1 plus K2 theta 2 whole divided by K1 plus K2. So this is the junction temperature when they will have the same cross section area and same length. It means option number 3 is the correct one. Third option is the correct. In the next question here. In the next question, a cylindrical rod having a temperature T1 and T2 at its ends, the rate of flow of heat energy is Q1 calories. How much the heat energy is given? Q1 calories per second. Q1 calories per second. If all the linear dimensions are doubled, all the linear dimensions are doubled, keeping the temperature constant, then the rate of flow of heat Q2 will be, the rate of heat flow Q2 will be equals to how much? That we have to calculate. It means the given condition, once again the same equation you apply there what we proved earlier. So this is Q by T is directly proportional to square of the radius and inversely proportional to length. Then Q by T of the first one is always divided by Q by T of the second one. This is equals to, this is R1 square by L1 whole divided by R2 square by L2. Then simplify this. What you get now? This is R1 by R2 whole square into, so this L2 goes to numerator, L2 by L1. It means this is we call, so this Q1 is going to be, this is Q1 and this we call as a Q2. This is equals to Q2. Therefore, apply the given conditions and now you can get the answer as of 2Q. Okay, so once you solve this, you'll get what? And 2 times of Q1 you will get. 2 times of Q1. Okay, option number 2 is the right answer. So in the next question, so that will be the condition which is related to the question number 7. A body of length 1 meter having a cross section area 0.75 meter square has a heat flow through the junction. So that is in terms we given as a 6,000 joules per second. Then find the temperature difference if coefficient of thermal conductivity is 200 joules per meter per Kelvin. So that you have to be calculated. Okay. If you have any doubt, you can ask. There is a question number 3. You maybe find there is a slight change. See, we are going to getting the answer as 6 into 10 to the power of plus 3 per minute you get. So here, so the answer is Q by T, which is going to be asked as what? Joules per minute is required. So it means the answer we got as 100 into the time is given as, that is nothing but what here? Per minute is there. So it means divided by 1 by 60 we can write here. So the 60 goes to numerator. So 60 into 100 is equals to 6 into 10, that is 60 into 100 can be written as 10 square. The what is the power for this? Plus 1. So when bases are same, power must be added or maybe subtracted, but both the sign will be positive. 10 to the power of plus 3 joules per minute. So this is the required answer. Hope you get the condition clear. Question we discussed, that is nothing but what? So this is Q1 by Q2 is equals to, so R1 by R2 whole square into, so this is L2 by L1. So this is equals to, that R1 is given as 1 by, because the single value. Then the second value will be doubled. The linear dimensions are doubled, no? That is why radius will become double. So this is 2 whole square into, so length will be 2 whole divided by 1. So this will be, L2 will be doubled with 2. So this is 1 by 4 into 2 whole by 1. So this is 2 by 4. 2 by 4 you get. So this is 2 ones are 2, 2 twos are 4. So this is Q1 by Q2 is equals to 1 by 2. Then we need to be find out this Q2 value. Then make a cross multiplication. So then 2 times of Q1 is equals to Q2. The required answer is this.
Same in series or the same?
In the second question, the shortcut is what? Remember, when the heat current flows in the first one is always equals to the heat current flows in the second one. dq by dt into second. This you will remember. That's all.